is the design process? What is the design process, and how we can keep having the loop of feedback to modify our design. So just let me put that on the paper. Okay. I just turn it on my camera. Just give me 1 second. Okay, and turn on the camera. Again, share my screen in 1 second. Okay. Now I'm going to make a flowchart, and this flowchart can be used by you guys to website, but I have a PDF for the pump. We download from it. No, actually, the document I shared with you have links, which we call as useful links or references for your pump design. And these things actually again to take you to multiple websites, and these websites are concerning with the design of the low-cost water pump for the poor countries. Now, the flowchart for the design procedure mainly going to be about the following: the product concept. Now, when we say the product concept, we're not inventing the wheel. It's already been invented. Whatever you design. Now, I think that sometimes you heard from time to time that certain country try to make a car, and then they stop because it's not cost efficient. They show you the thing, they maybe put that on use for a while, then everybody will forget it because they didn't do the study like that. Why I'm doing the things? The product concept is one thing. Then we're going to go all the way down to find out what are the obstacles we have, and always try to change the concept. So the product concept is how the things is working, or how the product is working. And of course, this will be the introduction you're going to have in your report. By using these concepts, you are going to make the initial design. So the initial design is yours using the same technology. Now the pump is obviously, as we mentioned earlier, is going to have basic types of the pumps. Either the valve is going to be different, the location of the valves are going to be different. That's another thing. The shape of the valve shaft is going to be different. We're talking about the multiple valve on the shaft, and the arrangement is going to be different. But in all the cases, we're talking about generating a negative pressure between the inlet and the outlet, and this will pump the water up. That's constant. That's the initial concept. You're going to make your initial design. You're going to choose one of these concepts or two of these concepts and mix them in your initial design. Next, you're going to check the following. I'm not going to write it down in, well, I would say design for manufacturing, DFM. Mainly it's going to be about, can I make it? Can I build it? How? And how to modify it? Simplify. So this will be the main core or main point we need to discuss in the design for manufacturing. For example, I can say that if I'm going to make the pump consists of less parts, this will be easier to be manufactured. because the time of the manufacturing is going to be less. So we're looking at, well, I know this will be extended, but we're looking at here less time to make the parts. Less parts count and standardized. Okay, so that's what we do in the design for manufacturing. We first asking ourselves, can I make it? When I say can I make it, is do I have the technology to make it? That's what we call the manufacturability. Can I manufacturing that or not? It's something like we are in the university, we're doing a project about the engine block. The engine block is made of the cast iron or the aluminum. It's going to require to have a foundry work, like making the pattern, making the mold, and do the melting for the metal and pour it. Okay, now we're talking about these. These are the basic manufacturing processes. The other way to do that is by having the injection molding. And in that case, again, to have the permanent mold. Again, to need to have the furnace to melt the aluminum and pour it in the mold. My question is, can we really make it? If someone asks, okay, now make the engine block. You wrote a beautiful report about that. Make it for us. Can we make it? What do you think? Why? Because we do have the knowledge. That's good. We have the basic knowledge, but we don't have the manufacturing tool. We call the manufacturing tool. We don't have the foundry. So still, this person who's the client, he wanted the part from us. He said, okay, I went everywhere and nobody can make it, but you wrote a good report about that, and I would like you to make it for me. What am I supposed to do? Again, to try to simplify. I'll try to simplify. I got to show you one video. Just give me 1 second. Well, it's not about, no, sorry, it's not about this one. I can show it to you later in my major project. If I cannot make the engine block by casting, I have to sacrifice something, which is spend longer time to make the block made of machining process. I can have the bigger block, have the same dimensions, and I'll try to remove the material on this block to have the shape of the engine block. Now, my question is, do you think that's possible? Let's try to find a video who can show us this process. Okay, so let's try to make a search here. We just write down machining. Engine block. So now machine engine block, again, to open this one later. And now we're talking about the 5-axis CNC machine V8 engine block. I don't know if actually this one's going to be just remove the material to have the thing, but I'm looking for something. Sorry, it's sorry, that's not. I know I'm not showing the sound because actually the app I'm using is preventing me from showing the sound. But actually, analyze that. What you can see, Zian, what you can see in this one, Morgan, Liam, let's have a discussion about that. We simplify the process. Instead of, if I don't have the casting, I can do the machining of the part because that's the equipment I have. That's the knowledge I can apply in my lab. I can have a CAD model. I can generate the program to cut the part, and I can make it. Now the limitation is going to be another thing. Does my machine able to cut this size of the engine block or not? Okay. Now you got my idea, guys. This is a part of design for manufacturing. If I cannot make it with technology 1, I can make it with technology 2. Now, do you think, I know that this is not the place to discuss in minor project, but check this video. It's called 5-axis CNC machine V8 engine block, and try to take some photos out of this video and add it as another technology for the engine block report for the minor project. Agree? So we will see actually through the video. We're going to scan the video and just skim the video, see how the thing is going to be made. That CNC milling machine with 5 axes. Now, the difference with the 5 axes, as I mentioned, that the table can rotate, and this will give you an extra 2 axes over the general milling machine, which have 3 axes only. So they start to remove the material. I showed this video because I know that the size of the engine block we're going to have here is not going to be a real big V8 engine, just a small one. And this can be compatible with the design we are going to have for the 2-stroke CNC engine. Oh, by the way, they just added the cooling fluid. What was the reason for this video for not using the cooling fluid during the cutting operation? Have you seen that the previous cut here, they didn't use the cooling fluid, and here they just added some cooling fluid on this stage, the white liquid. So what was the reason of not using the cooling fluid? Please turn on the microphone. Let's have some chat. It's going to be actually nice to have some chat. I like that. Yeah. What do you think that the reason they didn't use the cooling fluid in the earlier stage of the cutting?
Does having cooling fluid between the part and the milling bit, does that interrupt the surface finish? Like, does that create irregularities on the surface?
No, actually, the surface finish is going to be better if we're going to use the cooling fluid, because it's going to avoid the heating of the part. Now, you may don't believe that the only reason for most of the video we have that show us the turning or the milling operation, the only reason they don't have the cooling fluid is not yet. Yeah, the only reason is that because the cooling fluid during the taking of the video is going to hide the parts, so you cannot see actually what's going on. So they're sacrificing the quality of the work by stopping the cooling fluid, having what they call the dry cutting. So we will continue with that. You can see they remove the material, and they have the basic engine block. We can see that we have the ball, we have the coolant inlet and the outlets, these holes, and that's actually for running the water to cool the engine all the time. Okay, that's once again. Now you can see that's what happened if I again to use the coolant fluid. We cannot see what's going on in behind, so that's why they're doing the dry cutting in most of the video we have for the turning and the milling operation. Okay, so at the end, I don't want to actually see everything here. The most important thing for us is going to be at the end, they had that will be the tapping operation to generate okay, so they got an energy and flow. So now I just give you a hint that when you do design for manufacturing DFM, you look at, can I make it? How do I make it if I can? And how to simplify the process? How can I use different technology to make the thing? By the way, when I'm saying that, I'm teaching that to the advanced manufacturing subject student, that unfortunately you're not going to be able to get the same subject with the same structure. So I would like you to have a knowledge about that from now. You never stop. You never try to quit a job as long as you can find an alternative method to do the work. Now we go back to the camera and continue with the discussion about the design procedure. So with design for manufacturing, can I make it? How? How can I simplify it? Now the question is going to be, again, the design is going to be about how to have less time for the machining, how to make less parts, and how to standardize the items. Now, standardize the item in, again, to use the same item multiple times. And thus, I can manufacture this part by a method that can be a higher manufacturing rate. Get an example about that. You saw the CNC machine. I can simply make all the valve to be cut on a CNC machine. So the CNC machine is going to have the specimen start, or the work part, start to cut it to a multiple valves. Or I can do with the die with the plastic mold injection. So I can make 10 parts in 1 second. Or I can do the plastic casting. Okay, then I can make the valve in mass production. Maybe I can have a tray, and this tray have multiple cavity for the valve, for the food valve and the main valve, filled with the plastic, and then take off the valve and use it directly. Boom. I did a design for manufacturing. I standardize the items. I reduce time for the manufacturing. I only going to make the tray by having the one of the valves. I can make one of the valve and use this one as a pattern to make the multiple valve. Now, again, we're going to go back to this video, but we're not going to search for that. I'm going to try to do something else, which is the thermoforming. Forming process, and actually this will explain to you how we can make the tray by using the thermoforming process. We make one valve and use this valve as a pattern for the thermoforming process. I hope this will help you anyway. Okay, I got that. That's we call the thermoforming process. So I can make the valve by thermoform by casting, plastic casting process, making the mold with this method. That's one mold. I can repeat the process for 10 times and to have 10 molds. Then I start to pour the resin in it and make the what's called the plastic casting. Okay, you can get resin, and just simply as you make the ice block can do that. Different shapes are going to be made by thermal casting. We just pour the liquid resin in the mold. We just made with thermoforming, leave it to solidify, take it out again to be a valve. How much is going to cost you? Sorry, how much time is going to cost you? All the time required for the curing. which is not going to be actually a working time or machining time, because the worker will only going to pour the plastic in the mold and leave it to the next day. Next day is going to be solidified, take it out and use it. How many of you here agree that this will be a smart way to make the mold? You all need to machine the pattern and you're going to use it multiple times to make the molds. Do you think this will be a good idea to make multiple parts and reduce the cost in that case? So what I'm trying to do in this session, and actually when I modified the, well, I don't want to say I modified because we had discussion with the other. When we modify the project, is trying to gain you as much experience with the manufacturing method as we can. Just to tell you something that hopefully next year, the people will use actually these technologies in the lab. I mean, they're not going to make the hand pump anymore. We're going to have something we're going to discuss in the major project, which is going to be the gear pump. So they have to do multiple all the machining operations, and they need to do some casting, plastic casting operation to make the parts. So they make the mold, they fill the plastic, they can have the part directly. No time for the machining. The casting operation is not going to be costly. The only thing we're going to spend the time on is making the mold, and that's it. That's another example. But, okay, that's an example, but this was actually for an injection molding. And in all the cases, this liquid, and I can put in syringe and force it to fill the cavity of the mold, like injection molding. It doesn't have to have the machine to do that. Okay, now we go back to the list. I simply going to use less time to make the part. Use less part counting. Less counting. Because if I'm going to make 5 parts, it's going to be much easier than making 10 different parts. Standardize the item. Standardize the item. Using bolts and nuts instead of try to find something which is going to be quite complicated. If I'm going to have the bore of the pump that I'm going to make is going to, I always try to standardize that, so I don't have actually to make my own pipe. Just use what I have already. If I'm going to make it long life, I'm going to use the cast iron pipe. If I'm going to use it for short time, I'm going to use the PVC pipe. So when you are going to use PVC pipe or the cast iron pipe, you don't have to make your own. You just go make a search. The available sizes for the PVC pipe. Find that we have the 40 millimeter diameter, which actually 40 is for the outside diameter. The inside is going to be 37 or 38. You can use the 60, you can use the 80, you can use 100. That's what the available market. So we standardize the item. I standardize the valve because I need to do that by the casting. So I always going to have the mold. I can make use this mold to make multiple parts. Actually, taking out the plastic from the thermoforming sheet is going to be a very simple process. It's just like when you take the ice out of the mold. Push it from the back, you are going to get the valve and use it directly because all the dimensions are going to be accurate. That's designed for the manufacturing. Any question about design for manufacturing now? I give you 2 or 3 ideas, and we can go for the next step. Now, because we are discussing multiple ideas here, we check in multiple methods. This arrow should go forward and backwards. Because, for example, I need 3 students here from the same team, from the same group of the pump. Do we have any 3 students here for the same group of pump? Okay. Now, Callum, who's with you? Callum, who's with you? Oh, it doesn't matter. You are two. Doesn't matter. Now, you and who? Who's the other person? Okay. Now, for example, you decided to you suggested a certain design, and you made the design. You send it to Cooper. Cooper is going to be responsible for the DFM. Then Cooper will say, okay, now that's what we have as a method of the manufacturing, and we have this option. So you need to have a discussion. He will tell you that that's what we have. He's telling, okay, now yes. So again, to modify my design and send it back to you. You did the stage of the design for the manufacturing process. You finish with that. Next, we're going to go after design for the manufacturing. We try to reduce the cost as much as we can. By the way, design for the manufacturing, including the selection of the material. Because you know that the manufacturing process will be based on the material we're going to use. For example, I cannot do the sand casting if I'm going to use the plastic, obviously, right? So that's one other thing. So we need to do something else to lower the cost, and this will be the design for the assembly. Design for the assembly is analyze how much time required to assemble the pump. You can do that by making some of the what they call it assumptions. For example, we're going to have nuts, and we have thread, and we said, okay, now the time required to put the nut in position is going to be something about 5 seconds. I have 2 nuts, this will be 10 seconds. But in between them, I'm going to need to put the valve in the shaft. So I hope you can see that. So actually, that's what will happen. We're going to have the shaft going through the pump, through the valve, and we're going to have 1 nut here, another nut at the top. So of course, I need to make this nut first. This will be step number 1. Put the valve second, and put the other nut 3. So the time required to do that is going to be, let's say, 5 seconds, 3 seconds, and 5 seconds. Now, why 3 seconds? Because once again, we're going to have the hole, and we're going to have the road. I need to find my way to put that, and this will usually again take some few time. This can simply delay you. So 15 seconds just to make this one. And again, to have, let's say, another 5 minutes to assemble the whole pump. If I'm going to spend, well, if I'm actually going to do it multiple times, I'm going to have some experience on that. This 5 seconds divided by 60 minutes is going to be 1 over 5 over 60, 1 over 30 of the hours. You multiply that by the time, by the money you spend every hour for the worker who are doing the assembly, let's say $25. And this will be the assembly cost of 1 pump. Now, this will be good if I'm going to make in 1 pump, but we're talking about what will be the cost if I'm going to make 10,000 pumps. So the same cost is going to be multiplied by 10,000, and you're looking at something, right? For example, like $1,200. $1,200, that means we're going to add $1.2 for every pump. I need to reduce that. I don't want to have this cost to be added to my pump. I try to reduce that as much as possible. How we can do that? How much time is required? So how much it costs? can I reduce it? That design for the assembly. How can I reduce the cost of the assembly process? We're going to have multiple suggestions. For example, for this one, instead of having the valve at the top, we can think about something else. Like, for example, putting the a washer, which is going to be sit on a slot. We can make a slot during the manufacturing process, and we can push the washer on. Or I can make a design that the valve itself is going to have internal thread. If I get to have internal thread in the valve, I mean that the whole of the valve, this is the valve, the hole here, I can make it threaded. So in that case, I don't use the two nuts. Again, to simply just rotate it over the shaft that's going to be sitting in. That's an idea. You like the idea? So something like instead of having the valve to be sliding inside the shaft, and then we're going to have two nuts to hold it, I can simply make it as a threaded valve, and then I can have two turns. It's going to be held. That's it. It's going to take me something about 5 seconds. So I'm going to save 7 seconds just to assemble this part. You like the idea? I just give you an idea. Okay, so it's up to you to use that. You will have this video, and you can go back to it and take some notes. And I hope this will be useful for you. Okay, now that's the design for the assembly. And can I reduce it? Yes, I gave you one idea. The other ideas can be always be available. Like for example, for the bottom valve, for the food valve, actually, we're going to have. Okay, even for this one, we're going to have the washer at the top, so you can glue it instead of having the nuts to hold the washer or the rubber washer. You can simply glue it, and this will glue it on the valve, and it's going to be two parts together. The same thing is going to be happening for the food valve. The food valve is also going to have a washer, and this washer can be fitted on the valve by using a snap fit. If you don't remember what the snap fit is, I think that you saw something like this pin before. It's going to have a head like that. It's going to actually divide it into two parts. So when you push it inside the hole, it will be closed, then it's going to be open and fit. We call it snap fit. So you just need to push it instead of using the screw and try to twist the thing. We can use this one to fit the washer over the food valve at the bottom. Now we saved more time on something else. Now, what will be the other thing? Yeah, as I mentioned once again, the dimension, of course, of the valve can be varying depending on the diameter you are going to use. I know this will be more material to be used, but it's going to be actually substitute itself because we are going to have higher height for the pumping, or maybe higher flow rate for the water we are pumping. So this can be another option. Now, once again, design for the assembly, because we're suggesting many other items need to be used. So I need to send the feedback for the design for the manufacturing, because again, to change the list of the material or this list of the item has been made in this stage. And then we need to modify it and go back to here. If that's the optimum time required to assemble the pump, if yes, we go to the next stage. Design for the de-assembly. Don't spend too much time on that. It's only going to be about, okay, now if the time required to assemble the pump is going to be 5 minutes, what will be the time required to deassemble the pump? The de-assembly process is going to be affected by many factors. Like, for example, the material I'm going to use. Is it going to be affected by the water? and it's not going to allow me to deassemble the pump. For example, in this case, last time, student used a metal nuts, and the shaft is made of the aluminum. They put on the water for not more than 20 minutes. What's happened is that the nuts got rusted. When I went to the lab last month, I tried to deassemble the valves. I couldn't open the nuts because it's rusty. So you can talk about that in design for the assembly, using the plastic nuts instead of the metal nuts, or try to coat the shaft with a metal that with a material that's going to prevent the rusting, and this will going to make the time required for the assemble the pump is going to be the same as the time required to deassemble the pump, and this will make the assembly process easier. Once again, it's going to be two-directional work, and finally, we're going to have the design for recycling. Just classify the pump parts into the following categories. First, 100% recyclable. 2, non-recyclable. That means it's going to be and the scrap. We cannot use it. 3, reusable. I will give you an example for the recyclable. We're talking about the shaft, which is made of aluminum. Just recycle it. The nuts is going to be metal. It's got rusty. I can recycle it, but I cannot reuse it again. If the nuts are going to be still in good condition, I can reuse it. The main shaft of the pump, which is PVC, if it's going to be in good condition, I can reuse it directly, or maybe I can shorten it and use it for another application. That will be reusable. We have the outlet, like the T-junction. I can also use it again for another application. Non-recyclable, the valve is going to be made of a plastic casting. If they're going to be in good condition, I can reuse them. But if it's been used multiple times and the condition has been degraded, it's going to be end up as non-recyclable material. I need to scrap it. Again, this will be forward and backward because I can change the material I'm using here depending on the report I'm going to have for design for the recycling. Done? It's not. Because it's not only going forward and backward here, but also is going to have some feedback to the other processes. So every process is going to have the feedback to the initial design. Okay, so always going to have feedback to the initial design, and you are going to end up with final design. And the final design, usually in the real life, we're going to make prototype. And testing was prototyping and testing. Again, the prototyping and testing can go forward and backward to the final design because we need to modify something like the dimensions and tolerances. Make the prototype and the testing. If pass, we do the manufacturing process. But because manufacturing process is going to make the final product, we're going to have the customer opinion, and the customer opinion will change all the list of the study we made before. Okay, so I'm going to take the camera up so you can have a full image of this paper. And actually, the flow chart here is going to be what you need to follow to make the report for the hand pump report. I hope that's clear for you. Does this help you somehow, what we talked about today? Yeah. That will be also the structure of your report. That's your report. What we need to do is that in the initial design, we need to make the CAD models, and then we're going to modify it through the process. During that, for the design for the manufacturing, you need to write down what we call the route sheet for every part. Now, the route sheet, if you remember that in the casting operation, I'm going to leave it on the same paper. Route sheet is how to make the part, the machine process, the part. Okay, how to make the thing in steps. So step number one is going to be, for example, use 40 millimeter diameter PVC pipe. With length equal to, let's say, 60 centimeters. Okay, now first we describe what we are going to work on. Second, cut the pipe to, let's say, 45, 50, plus minus 1 millimeter length. Using the, well, let's say it's going to be the hand. So that's just an example. So what is the material I'm working on? What we're going to do to it, and new dimension. Okay, do the deburring operation. Both ends. Okay, oh, but it's just one end. That's it. Okay, so this is the process of cutting the pipe. So the pipe route sheet, use the 40 millimeter diameter PVC pipe, the initial length of 60 centimeter, just an example, or you don't have to mention that. Anything above, with length above 50 centimeters or 500 millimeters. Okay, and then you are going to cut it down to 450 millimeters. What we are going to cut it with, and what will be the final finishing process, which is deburr both ends by using the pipe deburring. Okay, and that's it. We have the parts made. We can simply say step number 4 is check the length. This will be the inspection process. Just check the length and ends quality, just to check if they are going to have any burrs or not just push it aside. Now done. That's an example of the route sheet. Now, what will be the route sheet? Can you give me an example on a route sheet to make the valve by the casting process? The threaded one. Can anyone, every one of you, type what you think the best route sheet we can write down to make the valve? That's again to say that we don't have to make the mold. We already have, sorry, the pattern. We already have the pattern. We already have the mold. The valve by casting operation, by the plastic casting operation. Just a reminder, for every route sheet, we usually get to put a hand sketch just to show because we send that to someone who's going to make it. We need to write down the hand sketch about this is original pipe. That's what I would like to have. 450 millimeter plus minus 1 millimeter, and put an arrow on the end to show that this end needs to be delivered. Well, I will show you the photo because actually it shouldn't be that hard. You are going to describe the following. We're going to prepare the what is that? The raisin. You're going to prepare the raisin material, mix it, add. You can describe what the percentage of adding the raisin to one, because we're usually going to have some additive to be added to. Okay, so you can mention what will be the type of the raisin we're going to use, the percentage of the mixing. You mentioned that we prepared pour it in the mold prepared earlier, leave it to solidify and cure for the time of 24 hours. Then take all the part out of the mold and inspect the dimensions. That's the steps. At the end, if you're going to have the thread in the middle, you can say that put the device on the CNC milling table on the table and perform the tapping operation to generate the internal thread with M6 millimeter. That's it. This will be the steps of making the valve and make it ready to be used. Let's talk about another part. Of course, for the shaft, the process is going to be the same. We bring a rod with minimum, let's say, 60 millimeter length, and then we start to cut it to the 50 millimeter, 500 millimeter length, plus minus 2, and well, once again, file the ends. So we're going to get rid of the sharp edges, and then we're going to do the thread operation on both ends. This another example of the route sheet. So the route sheet is the sequence of the machining of the part to get the final product. We start from the raw material, put the sequence of the machining in reasonable way. So we're not going to do for example, the threading of this hole before again to make the hole itself. So what's coming next, it should be at the end, not at the beginning. What's coming? Well, the raw material is what we start with, the processing of the raw material to be a semi-finished part, and the finalizing process. It's something like I'm going to write down something like that and send it to you, and you are going to make the part because you follow my I don't want to say instruction, my steps. Okay, so it's manufacturing instruction in real time. It's going to be manufacturing instruction for the people who make the processing of parts. All good? We still have something about 30 minutes, and the 30 minutes I'm going to use it to listen to what you think, and again to answer the questions. if you need any clarification of what we just discussed earlier. I'll be waiting. I'll keep the recording so you can go back to it.
I have a question, but it's about the minor project.
Yep. You want to ask it now, Liam?
Yeah, could I ask it now?
Yeah, you can ask it now. But are you attending the 6 p.m. Session anyway? Because for one reason, because I want more people to get benefit of your question. But go ahead, ask it now. I'm going to write it and tell it to the student later if you can attend the 6 p.m.
Yeah, I might as well just ask now. I just want to make sure. So if we use the dimensioned pictures that you provided, we don't have to make our own CAD model. Is that correct?
Yeah, you can, because actually at this stage, because of the condition we have for not being able to go to the lab, so just use the same images we have on the canvas. Cool. You can use them.
Yeah.
Okay.
So we don't have to make an own. No. Yeah. Okay.
No. But answer me this question honestly: why you don't want to make the CAD model?
It's just yeah.
Don't worry about that. Just answer me frankly. I need to get some of the opinions.
Yeah. Well, I just think if we have acceptable dimensions which have already been provided, I'd rather use those than spend time making something which we already have.
Good.
Which is my thinking.
Now, does that mean if I'm going to give you the dimension later for the gear pump, which is going to be the major project, are you going to be able to make your own CAD model?
I mean, if we had to make our own model for dimensions, then I guess I would. But I mean, like, I don't see the point of doing work which has already been done.
No, actually, the only reason I encourage the student to do that is because I would like you to get practice on the CAD modeling.
Right.
You may not need it now in this subject, but you are year 2 or year 3, and actually you are at the stage of finding the internship, which may be going to be your future work. If they find you doing very well and you know how to do many things, they will keep you. So don't worry about that. It's not going to be a part of the evaluation process of this subject. Because honestly, maybe this is your first subject with me, don't know me, but in the future, I hope if I get to meet in other subjects like the advanced manufacturing, if they're going to keep it or if we're going to have another one, I'm going to be part of it. My main target is not about, I would like to teach students something and I would like to test the student against it, and I want to see if they're going to be able to take my challenge. It's not about that. My main target is I would like the student to have the knowledge on how to do the thing. I want to make a student that are going to be proud of them, and they're going to be proud of themselves because they know more than the others from other university we have in Australia. That's my main target. So once again, I just want to remind you that after we're finishing this semester, I'm running something we call it the CNC programming course. It's going to be a short course for free, running on Teams, and I'm going to teach you how to write down the CNC code. I'm going to show you a short example about that. I have a simulator here, and I'm going to show you what we can do with that. What will be something like a magic, how to run a CNC machine, making the cutting tool moving and making the part. We would like to have something similar to the video we just saw when this guy actually had brought a block and finished with this shape. This CNC, unfortunately, is a trial and it's going to expire very soon, but still I can read down once again. What I'm going to do is I'll try to open an example. Do we have an example? Okay, let's try that. So you can use what the machine again to simulate. For the milling, we're using this example, the milling center. So it's going to give you the environment of the milling center. You can bring the part and making the cutting tools and make the part. I'm not sure about this one, but I'll try to give it a test. Yeah. So this is just an example of the machining process. Now, it's following a code. What you can see here is a code. And I'm going to teach you how to write down this code yourself, because this will be very useful for you in the future if you're going to have a work related to the manufacturing. This will be very useful for you to know how to write down this operation. Okay, so now I'm not going to do this one now. Okay, closing. Okay, so yeah, once again, if you don't have any question, you are free to go. And just a reminder that we're going to have the discussion session for the discussion session number 3 for the minor project, and it's not compulsory. I once again, all the sessions I'm making out of the class is not compulsory to be attend. It's made to help you, not made to force you to do something. So my recording is going to be stopped, and again.